Morning to all. According to our first video, we discussed data diffusion, dissemination concept. There we already completed the four concepts. So in this video, I'm going to discuss the fifth algorithm onwards. The fifth algorithm is directed diffusion. So here directed diffusion is a protocol is used in the scenarios where the sensor nodes themselves generate the request or query for data sensed by other nodes instead of all queries arising only from a base station. That means directed diffusion protocol is may useful in some scenarios where means the sensor nodes themselves. So each in the network we have number of sensor nodes. So in that any sensor node themselves can generate the queries or request for the data which may be sensed by other nodes. So here no need to only generate base stations. Any sensor node can generate the queries. That query may be sensed by any other nodes. Instead of all queries arise to only from a base station. So no need only base station wants to arise the queries. Here any sensor node can generate the queries and any sensor node can accept that. Hence the sink for the query could be a base station or a sensor node. So syncing. So already in the first video we discussed what is meant by syncing. That means it gathering the interest based on that it's seeking the information about that event. So sync means seeking for the information who required the data. That node will be called as sync. So here the sync may be any base station or any sensor node. Why? Because means here the sensor nodes generating the queries. So any sensor node, even base station is also a sensor node. They are also seeking the information, or any sensor node can seek the information in directed diffusion. So in sync, it periodically refresh its interest. So periodically the interest, I think we already discussed what is meant by an interest. Based on the interest only, the other nodes can provide the information. So in which concept you are interested, the other sensor nodes can provide that information. So the sync periodically refresh that interest, still requiring the data to be reported to it. Based on that interest, the other sync nodes will provide the data to these sensor nodes. So data is propagated along the reverse path of the interest propagation. So once if the sync node or any node wants data, it wants to generate interest, it wants to generate interest and it wants to propagate it in a path. The same path but are used to send the data that is given in this point. Data is propagated along the reverse path of the interest propagation. Then the next point in the directed diffusion is the path is associated a gradient. Gradient means a value that is formed at the time of interest propagation. So if that value is positive value, it encourages the data flow along that path. Whether if it is a negative gradient, it inhibits the distribution of data along the particular path. That means if the value is negative, it's not encourage the data flow. If the value is positive, it encourages the data flow in that path. That means in directed diffusion protocol is used to generate any sensor node can generate the request or queries for data sensed by the other nodes. Not only base station, anybody can generate the nodes and others can accept the data. So how the data is transferred means reverse path of interest propagation. So this is the concept of direct diffusion. Then the next concept is sensor protocols for information via negotiation. So these protocols is a family of protocols. So sensor protocols for information via negotiation, they are not a single protocol. It is a family of protocol and it is shortly called as SPIN, spin. So spin uses two concepts here. One is negotiation and second one is resource adaptation. So these 2 points are used to address the deficiency of flooding. Already we discussed the first point is flooding. So flooding means nothing but instead of the sending node, all other nodes are receiving the data in the form of broadcasting manner. So that is nothing but sensing. So they are sensing, sorry, flooding. Flooding may have number of disadvantages. To maintain or to avoid those disadvantages, spin using these two concepts. Those are nothing but negotiation and resource adaptation. Then come to the first point. Negotiation reduces overlap and implosion problem. So these two problems already we discussed in flooding disadvantages. So negotiation, by using negotiation, it reduces overlapping problem and implosion problem in flooding. And by using resource adaptation, that is nothing but here they are represented as threshold based resource aware operation, is used to prolong network lifetime. That means the third disadvantage of flooding, nothing but resource blindness. So with the help with that disadvantage, it reduces the network lifetime. To avoid that one or to overcome that drawback, here with the help of threshold based resource aware operation is used to prolong the network lifetime in spin. So in the spin protocol, the data is transferred in the form of metadata instead of transferring raw data. Then what is meant by metadata? Metadata is called as data about data or data describing data. So in the spin, the data is the raw data is not transferred. Instead of raw data, we transferring metadata. So due to this, it requires only few bytes and can be in an application specific format only. So instead of transferring raw data, we are transferring metadata. That's why it required only few bytes. So as easily as possible, we can transfer the data from one sensor node to another sensor node by using spins. Then the spin may have three different types of messaging techniques. Those are nothing but ADV, first one, and second one REQ, and third one is data. Then what is the first type of message? ADV. ADV means a sensor node broadcasts an ADV message containing metadata describing the actual data. That means we already know in MC we have clear to send, no, sorry, request to send, send and reply. Those concepts. If you want to send any data, first send the request and then get back the reply. In the same manner here also, if you want to transfer any data from one node to another node, first we transferring the ADV message. Then second point, the second point, REQ. If a neighbor is interested in the data, it sends REQ for the data. So if anybody interested for data accessing, so who are though access the RDB, then they given the reply to the neighbors. So I am interested on particular data. So to represent that one, they produce REQ message. So after generated the REQ message, the corresponding sensor node sends the data. That is the third point, data. Then the sensor node sends the actual data to the neighbor. So that means to transferring the data from one sensor node to another sensor node, these nodes using these three different types of messages. For request they are using ADV, and for reply they are using REQ, and after receive the request they send the data from one node to its neighbor node. So the neighbor node again sends ADV to its neighbors. Once again the same node wants to get the data, means he wants to send ADV to its neighbor. In the same manner the process is continues to disseminate the data throughout the network. So this is the three different types of messages in spin. Then now we are discussing the spin prototype. For example, in the total network, take two nodes, node A and node B. If node A wants to send the ADV message to B. That means he is ready to transfer the data. Anybody wants my data? So send that one in the form of ADV. So B receive that ADV, and so if he decide to get know the interest concepts, he send the REQ message to A. So then after received this request, then A sends the actual data. In the same manner, B can send ADV message to its other neighbors also. So in the same manner, repeatedly, if we do this one, then the data dissemination concept is prolonged. So in this manner, in the spin, we can distribute the data throughout the network. So this is the concept of spin protocol. Then the next protocol, seventh protocol is cast field approach. So it is a very simple approach. So that means the cast field approach consists the problem of setting up path to a sink. So sink means already we know if we want any information based on the event, we are providing interest. So who required data, that node generally we can say as sink. So if that node wants the data means they want to provide the path. To avoid the problems in setting up the path, we are using cast field approach. So in this approach, we have two-phase process. Two-phase process. The first phase is being setting up the cast field based on its metrics such as delays. So in the two-phase approach, first phase is setting up the cast field based on its metrics such as delays, that all sensor nodes are using same type of format. Then after a cast field path is set up, then second phase is nothing but being data dissemination using the cast which is set up in the first phase. Then based on these two phases and based on the cast, we can transfer the data. So if each node contain the cost. So cost is nothing but the minimum cost from the node to the sink, which occurs along the optimal path. So in the cost field approach, based on the cost, we find out the optimal path and we can transfer the data from one node to another node. And one of the important point in cost field approach is we may not need to maintain any explicit path information in this algorithm or protocol. So this is the concept of cast field approach. In cast field approach, the important point is two-phase process. First phase, set up the cast, and second phase, send the data by using that cast. So this is the concept of cast field. Then come to the next eighth concept is geographic hash table. So this is a slide, a geographical concept. Just come to the point. The geographic hash table is a system based on data centric, and this model or this protocol or algorithm or system is inspired, that means based on some concept. So he inspired, and this concept geographic hash table is designed. That's nothing but internet scale distributed hash table. Based on this DHT concept, the graphic hash table system is developed. Then what is mean by this graphic hash table means it contains some keys into the concept geographic coordinates is having. That means when you are drawing, we have some coordinates xy coordinates. Like in the same manner, in the geographic hash table also, it maintains some geographic coordinates and store them in the form of key comma value pair. Key comma value, like in this pair it stores in the networks, and that value is very near to sensor nodes hash values. Okay, so geographic hash table maintain a coordinates and store it in the form of pair, like key comma value. That value must be very near to the hash value of sensor nodes. Then it calculates the hash value is mapped to the unique node consistency, so that queries the data can be routed to the correct node. So when calculating the hash value, it must map to the unique node for consistency. Do not make any confusion. So maintain the redundancy. It provides a map to the unique node. Then we can route the data correctly to the nodes and store the data in replicant to ensure redundancy in case of node failures. If any nodes are failure, it stores the data in replicated formats, and consistent protocol is used to maintain the replicate data. So in that replicated format, the data is stored. To maintain that one, some consistency protocols are used to maintain that replicated data. So always data is distributed among nodes such that it is scalable and storage load is balanced. That means in geographic hash table, always data is distributed. That the storage load is balanced. So all the sensor nodes are maintaining similar type of data storage. That's why graphical hash table is more efficient in large sensor networks. So basically graphic hash table maintain the data in the form of coordinates format. The coordinates are stored in the form of key comma value. The value must be very near to hash value of the sensor nodes, and the data is stored in the form of replicated formats. To avoid redundancy, we are using consistency protocols, and these are mainly used for large sensor networks, and the data is also distributed. That's why the load is also balanced. So this is the concept of graphic hash table. Then the last protocol or algorithm is small minimum energy communication networks. This is a very easy concept. That means, just come to the point, small minimum energy communication network SMECN is a protocol to construct a subnetwork from a given communication network. So whatever the communication network you are taken, based on that a subnetwork is created for that similar concept. So whatever the network you are taken, for that a sub network is created. That means the entire sensor network is represented as G, graph G. The subgraph is represented as G dash, is constructed such that the energy usage of the network is minimum. So compare with the graph G. So what is the energy used in graph G? Compare with that, G dash uses less energy. So the number of edges in G dash is also less than of G, but all nodes of G are remained in G dash. So edges are same and nodes are also same in G dash. So whatever the nodes are there in G, the same things in G dash also. But the only difference is G uses large energy and G dash uses less energy. The connectivity between any two nodes is not disturbed by the subgraph. So connectivity is also not disturbed. G dash is constructed such that energy required to transmit data from a node to all its neighbors is lower in G dash than in G. That means we can transfer the data from one node to another node by using less energy in G dash than G. So this protocol simply says, by generating a small network based on our given communication network, we can, with the help of low energy, we can transfer the data from one place to another place without changing any physical structure of the network. Okay. Then based on these 5 protocols or algorithms, I designed some assignment questions. So those assignment questions are also 2 marks questions, and 5 questions are given to you. So those are: first one, write about directed diffusion protocol. Second one, define spin and write its types of messages. Third one, write about the cast field approach. And fourth one, describe GHT. Fifth one, write about SMECN. So write the assignment of these 5 questions and post it in my Gmail ID. And when you are representing the, when you are posting the assignments, so represent your name and your roll number, your section in the subject of your mail. Okay, thank you.